Hello, so today we are going to look at a method in Ruby called gsub that allows us to do string substitution using either a string or a regular expression. And so first let's just see the documentation here of the word, of the method. So it's a method on string, and it returns a copy of the string with all the occurrences of pattern substituted for the second argument. So what this means is that, so it will return the copy of this string, of this string that we apply it on after substituting all occurrences of the first parameter with the second parameter, right? So that would mean that, let's say we take this string. So if I take this string here and then apply this method here, you can see there, which is the first argument, was replaced by everyone, which is the second argument, right? We can also pass in just a regular expression instead of just a simple string. And so if I go back to the doc here, it says the pattern is typically a regular expression. If given as a string, any regular expression meta characters it will contain, it will be interpreted literally. What this is saying is just that if it's just a string, it will just interpret each character as literally and just replace, right? If you give a regular expression, it will look for occurrences of that and replace them, right? So this pretty much just says some things about, yeah. Okay, so now let's try this let's try it with this here, right? Let's try it with hello, and let's try to replace all these letters with star, right? So you can see E and O, which are here, are replaced with star. You could also pass in a block, right? Let's say if it's too complicated and it's not like, you can't really express what you want to replace with, sorry, first let's just take with a capture, using a capture here. So you can see, you could say whatever you found that matches this regular expression, just put it as the replacement, but maybe put it in a special form, like here, put it between these, right? So you can see what matches this here is E and O, and so we put them between brackets like this. Let's say, so basically, if you just do this, it will be the same string, right? This just represents whatever got matched, right? So let's say we want to put it between quotes, right? So you can see here it's between quotes. Let's say we want to put it between these, like, so you can see these separators, right? You could also just put one separator. So yeah, you could do whatever you want to put there. You could, and put the replacement in a special form. Now, if what you want to do is kind of complicated for a regular expression or for a simple string, you could create a block and pass it as a second parameter, right? So if I go back here, so what does this here do? So let's say you had a letter H, right? And just did and converted it to this, right? So it gives you the number representing the character, right? The number representation of the character. And so we could convert that to a string. And let's say for hello here, what we want is we want to get a concatenation with space between them of the number representation of each letter, right? So let's say for hello, we want to just replace the entire string with its number representation here. So how can we do that? We can't do it really with just a parameter like we did here with the second argument. So we need actually a function that does some work. And so that's what why gsub here supports a block argument, right? So let's see what this will look like. So if we run this, you could see it takes, for example, if I do just the letter H, the first letter, it's 104, so it takes that here. The second letter, which is E, it's 101, so you can see here, and because of this space that we concatenated, it separates them. You can make sure that, let's say, we put a hashtag between them, so you can see here, it replaced hello with this representation. So another thing we could do is we can pass a hash instead, right? And so when you pass a hash, what will happen is that for each letter, it will replace that letter with whatever the value is. So the letter would be the key from the hash, and the value is what it's going to replace it with. It doesn't have to be the same type. You can see here for this letter, the value is a digit, and for this one, the value is a character, right? So a hash, you could do it like this, but you could also just say hash new and pass this. So whatever hash representation you want. So let's see here. Let's see how this would look like. So if we replace this hello here, sorry about that. So if we replace this hello, every E and O, we want to replace the E with 3 and O with star. So you can see we get this. Maybe let's say we want to replace also L with, let's say with just a hashtag, right? So you could, yeah, so why didn't it work here? Because L is not in the list of things to look for, right? So that's why it didn't work. And so if we put L in the list here, we will replace it also with the hashtag, right? Now let's just take a little bit a bigger example here. So let's say we have this string, right? This string here, and then we want to replace every word between these two double column space here. So let's say we want to replace this column here, wave with and this here joy with an emoji, right? So this is usually the representation of an emoji. And let's say we want to replace any word that matches the emoji form, right? Which is it's between these columns here. Then we wanna get the image of the emoji and replace it with, right? This is what usually chat applications do, right? When you type something with an emoji word here. And so let's say we want to replace that, right? So we could just put the regular expression for the word and then capture it with these parentheses. And so now in the second replacement, we can use /1 here to represent that word that we captured here. And so since we have wave here, we want to go look for the image wave.png. And so that's what we want to replace it with. And the same thing with the emoji joy here. And so let's try this. So this is the string here. Now let's replace. So you could see we replaced wave here with the image representation to get the image and put it there, and the same thing with this emoji. But now let's say maybe some representations are not valid. Let's say text here, this is maybe not an emoji. And so we want to check and make sure we do have the image. And so let's say we have an array of these emoji lists that we have the images for, and we want to substitute only those that we have the image for, or the other ones we want to just leave them there. So we need, let's say we have maybe an array like this with the emojis that we have the images for, and we want to replace only these. So this is more complicated, so we can't do this string substitution, so we need a block for that. And so what we do here is we give the same regular expression, but we give a block here. So this start of do end is a block. We could also just do something like this, right? And then close the brackets, but we could also do it like this. So this means that we are passing this block here as a second argument to gsub. And so we check if the emoji is in the array. And so the gsub passes the argument that we represented here with /1. It passes it as $1. That's where it passes it to the function, right? And so we could just check if it's included, then get it from the image. If not, then just leave it as it is, right? So that, for example, here, Joe here won't get replaced because it's not in the list of emojis, right? So let's try this. And then we need to apply. So this is S actually. Okay, so you can see we replaced the one that exists in the array, but not this one. Another interesting example here that uses also a block is, let's say we have a list of passwords, right? And since we don't want to expose passwords, we might want to replace these, the values after the equal and before the ampersand for each one with just something marked as filtered or marked as hidden, right? And then and so we wanna replace that. And so what we want to do is first the regular expression of that. And so here the regular expression should be anything after password equal, right? That's what we want. And how do we identify that? We don't want to capture the ampersand, and right? And so we say anything that is not ampersand and plus, so that we capture even if someone doesn't have a password here. We don't want to expose that they don't have, that they have as a password an empty string. And so, or any other set of letters, right? And so we'll capture that here so that it gets passed as an argument to the block and in $1 here, $1, and we will replace that. And so we substitute it again. So you can see here we are substituting the entire string, but for each one of them we want to substitute this one here with just this hidden thing that says that the password has been hidden, right? And so you can see we are passing a block, and then we are passing as a parameter also the regular expression. And so if I take this string here, and then let's put the regular expression in a variable here, and let's replace, let's substitute that. And so you can see here the password got hidden every time, right? Another more complicated example is run length encoding, which basically is a concept that means that, let's say you get a string like this, and what we want to represent it in a compressed format, right? Where we say if we encounter multiple letters, we put the number of their occurrence, which is 2 here, and then we put the letter after that, so 2A. And for B, since the letters that occur just once, we just put them as they are, so we put B. And then we have 3 C's here, so we just put the number 3 and C. And then we have 1 D, so we just put D. And then we have 4 E's, and so we put 4 E. And so how can we transform this string to this string? So this is pretty complicated to do manually with just a while or a for loop, right? But with regular expressions, we can do them really easily, especially with the block here. So for in this string here, what 1 here means is that basically we capture whatever character in here, right? And so we have it. And then what this one here means is that, so this -1 is back reference, so it references what was captured before, right? And so it looks for the same text, right, as the one that we matched here in this capture, and then it looks for that character to repeat multiple times. And since we are doing plus here, means we are expecting it to either occur multiple times, either occur 0 or more times, right? And then in the block we get the match. So for this here, in the first case we will get AA, right? And then what we will do with that is that we will put the length and then put the first character, the first value, which is just A, right? And so that's what we'll be doing here. So let's try it. So if you take this string here, and then we replace it, right? So you can see it just does that. It takes, so basically if it's just one character, this would be nothing, right? And so the length won't be there, right? And yeah, so that gives us the exact matching here. That would gives us exactly what we want here, right? Now let's take this more complicated string here. So you can see it has a lot of W's, and so if we substitute that, you can see we have 12W, 1B, and then 12W again, and then 3 B's, 24 W's, and then B, right? So you can see it's pretty handy. Now let's try to see what do we do if we want to decode it. If we get this string, right? Can we do that with the regular expression? If we get this string and we want to get back the reverse, right? So we want to get back this, right? So if we want to decode, let's say this string, we want to decode it back to here, we can also use the regular expression, right? So I wrote it down here. So we can look for occurrences of numbers and the letters after them, right? And then what we want is, so we will get for each one 2A, let's say, and then B, and then 3C. So for 2A, right, so the last character is A, so that's the letter here. And we want to multiply it so that it can occur 2 times by this here. And this here is just match 0, or you could just do match to I. Why is that? Let me just run this on an example here so you can see. So if I take this string here, right, just copy it. And just to show you the matches, let's first just do something like this. So we want to just show you what got matched, right? So we say match equal to match. So we can just print out what got matched, right? So here you could see for this string here, we match it 2A and then B, and then sorry, we match 2A, 3C, and then 4A, right? So B, we didn't match it, so we'll leave it as it is, right? And so we match, because that's what we want here. If it's just one letter, we don't want to change it, right? We don't want to substitute it, so we can see it didn't match here. All we matched is our letters that are followed, sorry, our digits that are followed by a letter, right? So we got 2A, 3C, 4A. So each match here is either 2A or 3C or is of this format, right? So what are we doing? We are taking match minus 1. So let's take this case here. Let's say match is just this one. Let's put it in string here. So match minus 1 would be the last character, right? And then, so it's the letter that we want to multiply by the number 2, right? Because if we multiply in Ruby a string like this one, we will get it to occur that many times. Let's say multiplied by 5, we'll get it to occur 5 times. And so here, if we also take match to I, right? So let's say match here is to A. So match to I is converting it to an integer. So it will skip the letter, and it will, because to I for a letter is just 0, right? So it will just give us 2. We could also just do match 0 to I, just to simplify, but match to I also works, right? So that means that this block here will take A and multiply it by 2. And that's exactly what we want. It will take C and multiply it by 3 so that it occurs 3 times. And so if we take the entire substitution here, S is this, you can see we get the exact thing that we want, 3C and then 4A, 4E's. And so you can see this is really simpler. So if we take this second string, we want to get this one back, right? So if we take this string, and then we do the substitution again, you can see we got the string that we encoded back, right? Yeah, so that's it for the gsub here. It's very useful. Yeah.